Hey guys, this is Moib here from the University of Greenwich. In this video we're going to go on to look at more circle problems, and we're going to start off with one example I've got on the board here. So we've been asked to find angle X and angle Y, and this is the diagram we've been given. Immediately we can spot that we've got two angles which are being created by the same 2 points, okay, and now these angles meet at the midpoint and also meet at the circumference. Now in my earlier video I explained how there's a theorem for this. We know that the angle that is created at the midpoint by 2 points is the same as the angle created at the circumference by these two same points. The angle that is created at the midpoint by 2 points is the same as the angle created at the circumference by these two same points. Okay, so if we're trying to find out x, we're going to know that this is going to be 2x. Okay, this is from our first circle theorem. If you haven't seen that earlier video I'm talking about, do go over and brush up on some of the theorems that you may have forgotten, okay, because these are going to be important in your exam. So moving on, what we got to do is we got to find this angle here that is made by COA. That's an A, sorry. COA. Once we find this angle, we can find x. Okay. It wants us to find out x and y. Let's start by finding x first. So in order to find this little angle here, we can use the fact that this angle here is 31. We can draw this out here, and this will be a lot easier to deal with. Okay. So we've got a midpoint. That's the angle we're trying to find. A and C. Angle at A is 31 degrees. These two lines here, if we look carefully, are radii. So these are of equal length, okay, as they go from the midpoint to the circumference, midpoint to the circumference. So these two are in fact the same. When these two are the same, we know that these two angles are in fact going to be the same also. Okay, we've got two of the same length, so these angles are going to also be the same. Now we can work out this mystery angle. Okay, all angles of a triangle need to add up to 180. This means that these three angles need to add up to 180. So let's denote our mystery angle as a Z. Okay, so Z add 2 times 31 will equal 180. So if we rearrange this, we got Z equals 180 minus 62. Z equals 118. Okay, so we've got that this angle, our Z, is 118. So we can write this out here, 118. Now we've worked out our angle COA to be 118 degrees. Now we can half this to work out what x is using our first circle theorem. To find out x, all we do is half of 118. This gives us x equals 59 degrees. So now that we've worked out x, we can work out our y using a theorem which I actually didn't go through in our previous video, but you should be already familiar with this. It's a formula that you always use with quadrilaterals. If you look at the shape that is created by A, B, C, and D, A, B, C, and D, you can see that this is a quadrilateral. Right? So the rule that we get for quadrilaterals, so let me draw any quadrilateral. We know that opposite sides, A, B, C, and D, add up to 180. So A plus B equals 180. C and D also equal 180. This is the quadrilateral rule, which I'm sure you must have come across, and we can also implement this into circle theorems. Okay, so now that we know that opposite angles add up to 180, we can see that x and y are opposite angles of this quadrilateral. I'll just go over this quadrilateral with my black pen. just so that you can see it. And you can see that x and y are opposite angles. So if x is 59, these opposite angles need to add up to 180. So 59 add y, so that's x plus y, must equal 180. Rearrange this so that we've got y equals 180, take away 59, to give us y equals, what was it, 121 degrees. So now we've worked out an angle of x and an angle of y.